Hi, my name is Josh King, and today I'm going to be giving a presentation on optimizing Wi-Fi traffic for students at Greenwich High School. So the fundamental problem is that the Wi-Fi speeds at Greenwich High School are slow and inconsistent. The Wi-Fi speeds decrease significantly during certain times of the day, such as in the morning when a lot of people are in the student center trying to finish homework, or during lunch when everyone is on the Wi-Fi trying to do homework. Web pages and other services, including mobile apps, load very slow or don't load at all, and network speed is slower or faster depending on the location, such as the student center has much slower speeds than the media center. So the problem does not happen on a wired connection. What I mean by this is that the school-provided desktop computers always have very fast, reliable speeds, and I'm sure many people have noticed this. This means that it's a problem with the Wi-Fi, but not the actual network. So it's only the wireless component of the network, but not the entire network. There are three SSIDs in our school: GHS Guest, GHS Instruction, and GHS Faculty. For this presentation, I'm going to be focusing on GHS Guests. Each of the SSIDs have dedicated access points. Access points are those little boxes that are mounted on the ceiling that give the users Wi-Fi. Each of the SSIDs also have different speeds. If you look at this graph, this is a sample of the connection speeds on a certain day between 7 o'clock and 8 o'clock in the morning. Notice how between 7 o'clock and 7:20, when there are not as many students, but the students are starting to pour in, the Wi-Fi speeds gradually decrease until you get to 7:20 and to around 7:30, where the Wi-Fi speeds are very, very slow. This is because there's a lot of people at once in the student center trying to use the Wi-Fi at once. As soon as the bell rings and everyone goes to their respective classes, the Wi-Fi speeds then increase until around 7:50 when almost everyone is in class. To tackle this problem, I investigated two solutions, one hardware-based and one software-based. Here's a hardware solution. There are three options for the hardware solution. The first is to buy newer, higher throughput access points, essentially upgrading our current system. The second is to buy more of the same Wi-Fi access points. This will essentially just expand our current existing network. The third one is to replace our current network with larger number of cheap but low throughput access points. Each of these three options have various cost implications and also require installation as well as maintenance. This is the access point we currently use at our school today. Each of them costs anywhere from $450 to $500, and they all require maintenance of about 15% of the initial cost per year. These access points are built to be scalable for large buildings like Greenwich High School, but they're very vulnerable to interference because they use a 2.4 gigahertz range, which is a commonly used range for radio signals. So for example, if there's a walkie-talkie using the 2.4 gigahertz range, it could definitely interfere with the Wi-Fi. If you were to upgrade our current network with more expensive but higher throughput, higher performing hardware, it would definitely fix our problem and it will definitely increase speeds. However, it will incur a very high cost. If we decide to add more of the existing access points to our current system, it could definitely solve our problem, but not as effectively, but it won't be as expensive as the first option. The third option is to replace our current system with many lower quality access points. While this is definitely the cheapest option, the results will be inconsistent or marginal. Now let's take a look at the software solution. I propose we implement what is known as a mesh network. So what is a mesh network? A mesh network is an alternative configuration of a Wi-Fi network. Every user connects to each other and data is passed along the least crowded path. A mesh network balances network traffic automatically and does not require additional hardware. So what does this mean? So say you have your network backbone. This is the router and all the other network equipment associated with it, and you have the Wi-Fi access points connected to the backbone. You then have a bunch of computers and phones that want to connect to the Wi-Fi and essentially to the GHS network backbone. In a traditional configuration, which is what we have at our school today, the computers or phones would directly connect to the nearest Wi-Fi access point. Now let's take a look at what this would look like in a mesh setting. You would still have your Wi-Fi back or network backbone as well as your Wi-Fi access points, and you will still have your computers and phones wanting to connect to the Wi-Fi. The only difference is that before the computers or phones connect to the Wi-Fi, they first connect to each other and then to the Wi-Fi access point. Note that there are a lot more routes on each computer or phone available to them. This is an advantage because the computer or phone now has more options to route the traffic and can determine which path has the least amount of traffic on it. So let's take a look at what this means in the GHS context. Say you have the student center with 100 users in it and the science wing with 20 users in it. You have your backbone and you have your wireless access points. The student center users will connect to the Wi-Fi access point in the student center. The science wing users will connect to the Wi-Fi access point in the science wing. On the right, in the student center, the Wi-Fi access point will have to handle 100 users worth of data, which is a lot of data, and it will overload, giving the users very slow speeds or no connection at all. On the left, the Wi-Fi access point will only have to deal with 20 users worth of data, which it can definitely handle and is underused. As you can see, both sides are unbalanced. Now let's take a look at what this will look like in a mesh configuration. So you have your network backbone, and you have your Wi-Fi access points, and on the right you have your 100 users worth of data, and in the science wing you have 20 users worth of data. Now, this is where you connect to the mesh network. The mesh network is a common mesh network shared between the science wing and the student center, and the data goes into it. The mesh network then balances both sides and outputs an equal amount of data. So by very simple math, 100 plus 20 divided by 2 is 60. So the mesh network will then output 60 users worth of data on the right and 60 users worth of data on the left. Since this is not that much data, but is definitely enough data to make the Wi-Fi access points use to their full potential, both sides are happy. So how would we implement a mesh network at GHS? Well, first, every user will have to install an app on their phone or computer. The app connects the device to the mesh network, and no additional configuration should be necessary. The software will automatically balance the traffic and increase that user's Wi-Fi speed and help other users get faster speeds. So what are the benefits of having a mesh network? First of all, and most importantly, it will cost literally nothing. It's just software, you just install it, and you don't have to pay any money for it. Second point is that the more devices you connect, the bigger and faster your network becomes. This is because of the nature of the mesh network. So if you have more computers, that means there will be more routes available for the other computers, which makes the mesh network more effective. A mesh network relies on the same Wi-Fi standards as the network already in place, which means that there's going to be no compatibility issues, and all Chromebooks can be pre-configured to use the mesh network. Mesh networks are also used in places like carnivals or concerts where there's few access points and a lot of people, or disaster zones in third world countries where there's not enough hardware or there's not enough resources to set up a proper network. Another benefit of a mesh network is that it can route around large obstructions. A large obstruction can be anything like a physical obstruction where there's a big building in the way, or it can be a virtual obstruction like a spike in radio waves emitted by something like an electronic transformer. The mesh network will be able to route the traffic around the obstruction to the access point on the other side. Mesh networks are also self-configuring, meaning in a traditional network, the administrator will have to go in and configure a whole bunch of stuff to add new hardware. In a mesh network, that is not necessary at all, and by design, the mesh network will be able to incorporate new hardware very easily. Mesh networks are also self-healing, meaning if you remove one piece of hardware or one computer from the mesh network, the software is smart enough to route you around that hole. Wireless mesh nodes are easy to install and or uninstall because it is purely software. Meaning, if we install it in Greenwich High School and if it doesn't work, all you have to do is uninstall the app to get rid of it. So here's an example of a mesh network that is used today. In Havana, Cuba, the government heavily controls the internet, and for most people in Cuba, it is not accessible at all. The way the Cubans got around this was that they set up their own mesh network in Havana. By using the mesh network, the users in Havana that weren't able to access the internet before can now play video games, they can talk to each other, and they can send files to each other through this mesh network in Havana, Cuba. They can also use this mesh network to access the outside internet that is not censored or restricted. Cubans in Havana were not able to communicate with each other and essentially not use computers before this mesh network, but because of this, they are able to exchange information. So let's look at different types of solutions for mesh networks. The first one is IPFS, the Interplanetary File System. This is a distributed file control system that uses torrenting technology to store data. What this essentially means that it sets up a mesh network and then all your files are stored bit by bit on someone else's computer. This is a great solution if you wanted to use a mesh network to ensure that your files will not ever be lost or modified in ways that you don't want. However, it's not really meant for load balancing, so it's not really applicable to Greenwich High School. The next solution that I investigated was CJDNS. It is a distributed peer-to-peer alternative to the internet, and the goal of the project is to implement a distributed model of the internet while addressing many insecurities found in modern protocols. Basically, the project wants to replace the internet with a better version that addresses a lot of the problems that are found on the internet today, but is really not meant for local settings because it requires dedicated servers. So this is not very applicable to GHS either. Next solution, Netsukuku, is a similar to CJDNS. It's a more widespread, larger scale mesh network that aims to replace the entire internet with a complex mathematical model that sees the entire internet as a fractal. However, while this could technically work, it's designed for a much larger scale operation, and it probably is not suitable for a school setting. The last solution is Batman. Batman stands for Better Approach to Mobile Ad Hoc Networking and was developed by German developers Freefunk. Written in the C programming language, it's designed for local networks like GHS and generates a very low amount of overhead data. Overhead data is the so-called metadata, the data about the network that should be minimized to give the best possible speed. My recommendation would be to deploy a mesh network using the Batman protocol. How you would do this is that you would use a dedicated app that will install, configure, and connect Batman for your device. This app will be able to connect and disconnect from the mesh network with one button. You will be able to see connection statistics, tweak settings, and look up help all in the same app, and you will be able to send files to others connected to the mesh network, all in this one app. So why did I choose Batman? Well, Batman can work with anywhere from one computer connected to theoretically an infinite number of computers. So it's infinitely scalable. Batman also will definitely address this issue of Wi-Fi speeds and will solve our fundamental problem. Batman is also very easy to deploy and was designed with this problem in mind, the problem of Wi-Fi speeds and overcrowding in one area. Batman is also multi-platform, meaning that it will run on OS X as well as PC. Batman is also completely free, which gives it an advantage over the hardware solutions. So here's an example of the GUI that I thought of for this Batman application. So you would have a main window with a connected status, and optionally you could see other statistics about the network. and you'll have a connect disconnect button, and then you also have a settings button. If you hit the settings button, it'll bring up a new window with a bunch of settings that you can configure. You can see logs, and you can see help as to how to use the app. Thank you for your time.